In this video, we're going to look at how to name organic compounds. So here are the four basic rules of how to do it. The first one is we have to identify the longest possible carbon chain. And then in the second, what we do is we identify if there are any substituent groups such as a methyl group. This is a methyl group. If you do not know how to name alkyls, there is another video which I'm going to link. You can go and see what alkyl groups are and how to name them, or an alcohol group, and etc. All the functional groups that there can exist. And then the third rule is we will always have to number the chain from the end that will give the lowest number to the substituent group. So if we look at some examples, we'll see what I mean by that. And then the last one is we have to, if you have multiple substituent groups, which is if you have multiple functional groups attached to the your chain, what you would do is you would have to name them alphabetically. You just kind of name them randomly. So we're going to do some examples, and hopefully that will clear everything out. So this one, the longest possible chain is 3 carbons. So 1, 2, 3, and we cannot see any difference. We don't see any substituent group here. These are all hydrogens. So this is straightforward. This is propane. So we're going to move on to this one. This is not a displayed formula, but you get the idea. You should be able to imagine how this should look, the display formula of this should look like. So the longest possible chain, I can number it from here, 1, 2, 3. So I can see there's a branching here. So this is the substituent group here, which is a methyl group. So consequently, I can also number it from this end, 1, 2, 3. And either way, the substituent group is always in the second carbon, so it doesn't matter which side I number it from. So this is the methyl group. You might also say that, hey, how about I number the chain like this, 1, 2, and this is the third carbon. That's fine. Then this group becomes the substituent group, and the substituent group is in the second carbon. So you still have the same thing. Anyway, we're going to keep it simple. We're going to keep it simple, make it look like this. So this is our substituent group, which is on the second carbon, and the longest possible chain has 3 carbons. So I know that it's going to be a propane. But I have a methyl group. This is a methyl group, which is bonded to the second carbon. So it's going to be 2-methyl propane. So the number immediately before methyl tells us where the methyl group is on the propane. So this one, we have an OH group, and in another video I have shown how to name functional groups. So when you have an alcohol substituent group, it's going to end with a suffix "ol." And I'm going to first do what I'm going to do according to these steps. I'm going to identify the longest possible carbon chain. So I have 1, 2, 3, 4. I have 4 carbons. So I know it's a butane. But look, if I number it from this end, my substituent group gets 3. But if I number it from this side, 1, 2, 3, 4, the substituent group is on the second carbon when I'm numbering it for this side. So this is what I'm going to do, because this is our rule number 3. Number it from the end, that will give the lowest number to the substituent group. So we're going to do this, and we're going to ignore this numbering. So this is an alcohol. The OH group is on the second carbon, and I have 4 carbons. So it's going to be butan -2-ol. Again, the number is just before the functional group ol. This tells me that the ol is in the second carbon. In other words, this tells me that the OH is in the second carbon. So now we move on to this example. Clearly, this is a carboxylic acid group. This is a carboxylic acid group. And we know that carboxylic acid groups end in oic acid. This is the suffix. So I know for sure that that's going to be there. Now I just have to number the number of carbons. So always remember that if I number it from this side, then the carboxylic group's carbon gets the highest number, which is not right. We can't do that. So for carboxylic acids, always that carbon is going to be 1, 2, 3. So this is going to be propanoic acid. Propanoic acid. Now we move on to another example. So here, my first task is to identify the longest possible chain, and clearly, if I say that 1, 2, 3, so this is my longest chain, and this whole thing is my substituent group, I'm wrong. This is not possible because the longest possible chain doesn't always need to be straight line. So in this case, actually, the longest possible chain would be 1, 2, 3, 4, 5. So this is my longest possible chain. And this guy is my substituent group, methyl group. So the way I would name it is the methyl group is in the second carbon, and I have 5 carbons in the chain, so it's going to be a pentane because of the 5 carbons, and the methyl group is in the second carbon, so I'm going to say 2-methyl. If you had an ethyl group, you'd say 2-ethyl pentane, and so on and so forth. So now we move on to this guy, and now again, 1, 2, 3. This is my substituent group, and halogens are named as halo in the prefix. So in this case, it's bromine, so it's going to be bromo in the prefix. So, but where is the bromo? On the second carbon. So 2-bromo, and I have 3 carbons in the chain, propane. Now, here's something that's interesting. When you have carboxylic acid groups, so you know for sure that this is going to end in oic acid. But then again, you also have a hydroxide group, an alcohol group. That also ends at ol. So what are you going to do? So for this reason, always remember that when you have a carboxylic acid and also an alcohol functional group, this guy, we are not going to use ol anymore. But we're going to say, we're going to use a prefix, it's called hydroxy. We are not going to use this. We are not going to use this name. But instead we're going to use hydroxy because I cannot use 2 suffixes to identify 2 functional groups. So in this case, I have 3 carbons, and again, carboxylic acid's carbon is going to be the first one, and I have the OH group in the second carbon. So I'm going to say 2-hydroxy propanoic acid. So the red part comes from this, the black part is for the chain, and the blue part is for the carboxylic acid group. So this is something to remember. So I'm going to look at a few more examples. So in this case, first task is to identify the total number of carbons in the chain. So that's 1, that's 2, that's 3, that's 4. But if we go and check the rule, it says that name the substituent groups alphabetically. So for this substituent group, it's bromo. For this substituent group, it's chloro. But notice that chloro starts with C, bromo starts with B. So B comes first. It's just a reminder that it's not the symbol of the substituent group that we're looking at. It's the name of the substituent group. So if there was a methyl group here, we wouldn't say that C is the alphabetical order. C is the thing that we're going to look at. No, methyl groups are named methyl with M. So you're going to look at M. So I'm going to do another example. So it's going to be clear then. So in this case, bromo's B comes before chloro's C. So this numbering is not going to work. So what I'm going to do is I have to number it from the other side so that bromo gets the lower number. So this guy is going to be called 2-bromo, 3-chloro, and I have 4 carbons in the chain, butane. So it's going to be called 2-bromo, 3-chlorobutane. And again, always remember that we use dash between letters and numbers. In this case, I have 2 substituent groups. I'm going to number it from this carbon so that the substituent groups get the lowest number, 3, 4. And now what do? So we have 2 chlorines, and both of them are in the second carbon. So what we're going to say is 2 comma 2. This is the position of the first chlorine. This is the position of the second chlorine. So we use commas between numbers. So 2 comma 2, but I have 2 chlorines, right? So I'm going to say dichloro. And then the chain is 4, so dichlorobutane. So if one of these chlorine was here, you would say 2 comma 3 dichlorobutane. You would say it together. So when you have the same substituent groups branching out, you would tell them, you would specify them together as di, tri, and so on. So let's imagine that if I had another chlorine here, right? Let's just do that. Let's imagine that I have another chlorine here. So in this case, I'm going to get rid of this 2 because I cannot have the carbon bond to 5 things. So let's say this is something that it looks like. So what I'm going to do now is what I'm going to have here is 2 comma 2 3. Then this is not going to be di anymore. So this is going to be trichloro. Now I have 3 chloro substituent groups, right? So 2 to 3 trichlorobutane. So this example, again, the substituent group here is methyl. I'm going to identify the longest possible chain, 1, 2, 3, 4. So I have 2 of them. At the second carbon, so I'm going to say 2 comma 2 dimethyl, because I have 2 methyls. It's very important. People forget this. Dimethyl butane. Here, it's pretty straightforward. Oh, hold on. I didn't finish writing it up. So if I have something that looks like this, so alphabetically, chloro, right? And this guy is going to be 1 because chloro C comes before methyls. This is one substituent group, this is another substituent group. So chloro C and methyls M, this guy comes first. It has the first priority. So this is my first carbon, second carbon, third carbon. So the way I would say it, as they're different, I have to specify in a different way. So it's going to be 1 chloro dash 2 methyl propane. That's how you do it.